Good evening, everyone. This is Mohammed Zain, Assistant Professor, Faculty of Civil Engineering, Sri Ramsal Memorial University. Okay, today I think I have given my introductory video previously for this course. Now we are starting with lecture one, that is concept of vibration. Okay, and after that we will cover other topics as discussed in the introductory video. Okay, now let's start. So vibration. See, you must be knowing what is vibration. Vibration, as written here, is the motion which is repeated continuously. An interchange of energy take place, or any motion which repeat itself after an interval of time is called vibration. Okay. Just give a bit of focus here. See, I am having a pen here. This is a pen. Okay. What I am doing, I'm taking out this refill and making it into go vibration. Okay, let's have an example here. See, this is a pen. Okay, refill is here. Now I'm putting a force here and letting it to vibrate. Okay, this. See again, watch it. See what happened here. The you can say a large amount, you can say an amount of strain energy was stored in this. Strain energy, elastic energy was stored, and it went to kinetic energy. Again, that energy was stored until and unless this process goes on, until and unless the body comes to back to its equilibrium position. So when it comes back to its equilibrium, the vibration stop. This is just an example to let you know what is vibration. So if you think more about vibration, see, uh, everything in this world is in vibration. That's a fact. Every particle, every molecule, even you are in constant in vibration. But it's the fact that in which aspect you are, from which aspect you are seeing it. See, uh, our molecules, if you see at the molecular level, every molecule is in constant motion or in constant vibration. That's a fact. Okay. Now let's move on. Now, what is dynamic loading? See what happens. When, as written here, a dynamic load is any load whose magnitude and direction changes with time. Okay, it is rightly written here. Okay, a dynamic load is any load whose magnitude and direction and position vary with respect to time. Okay? And you can see if any load is changing with respect to time will come under dynamic load only. For example, earthquake load, blast load, these load will come under dynamic load. Wind load will also come under dynamic load, and traffic, evenly moving traffic on any structure will also come in dynamic load only. Now, the analysis of dynamic load can be done by two methods. First one is deterministic analysis, and the second one is non-deterministic analysis, as written here. You can see here, deterministic analysis and non-deterministic analysis. These are the two methods available to analyze the dynamic load. Now, in uh, deterministic analysis, what happens? The structural response, that is displacement, displacement, acceleration, acceleration, velocity, velocity, stress, stress. These three, four things and etc. and many other variables are completely known or precisely known as a function of time. See, in deterministic science, all these elements are completely known as a function of time. It is known as, you can say, a deterministic analysis. Okay? Or you can do the analysis there only. For non-deterministic analysis, these like displacement, acceleration, velocity are not completely known. Okay, only you have some statistical information about the response. Okay. Or you can say the deterministic analysis, also known as it is also known as random dynamic loading. Random dynamic loading. Okay, now moving on to our next slide. Now, types of prescribed or deterministic loading. Okay, there are basically two types of deterministic loading available. This is periodic loading and non-periodic loading. As the name suggests, if the load is repeating itself after some time, for example, a rotating machine here, or the propeller forces at the stem of the ship, these forces or these type of loading are called as periodic loading. Okay, if the load do not repeat itself with a time duration within a time duration, or you can say the load is keeping on changing with respect to time, for example, like bomb blast loading or earthquake loading. Okay? These type of loading is called non-periodic or aperiodic loading. Now moving on to the next slide. See, uh, there are basically which we have earlier discussed about the dynamic load. Now, static load already we know about it, and it is not changing with respect to time. For instance, you take an example, a beam is over here, and a load is kept over here for the entire span of time. This will come under static loading. Okay, now here's some of the difference between the static and the dynamic load. See, first point here, in static problem, load is constant. Obvious, load is constant with respect to time. In dynamic problem or load, we can say the dynamic load is time varying in nature. Okay, a static problem has only one response, obviously, but that response will be what? Displacement only. Like a load is kept over here and only a displaced formation for this beam will be there. This will be the displacement. Okay, now dynamic problem has mainly three responses. Okay, that can be acceleration, velocity, displacement. Static problem has only one solution. Okay, but the dynamic problem can have infinite number of solutions, you can say. It depends upon the situation which method we do have to adopt for this, for a for a single dynamic problem. Okay, in static problem the response can be calculated by the principle of force and static equilibrium. Obvious, it is very much obvious. Okay, in dynamic problem the response depends not only upon the load but also upon the inertial forces which opposes the acceleration producing them. See, what we were in starting, we have taken the example of that refill. See, that was kind of going into a dynamic analysis because the force, you can say, I have applied it, it went into free vibration, although, but an acceleration was there and inertial forces were developed in there. So that was the case for that. So dynamic problem will have many responses, you can say. Okay. Now moving on to our next slide. Type of vibration. There are different types of vibrations are there. We will go through one by one. Now, first one is your free vibration. Okay. Now, what is free vibration? See, uh, uh, if a body, or you can say a structure, went under vibration af and the force has been removed from there, like previously, if this is a structure, you can say I am applying a force over here and I am removing it, Actually, it is going under free vibration only. Okay, but the force, or you can say the displacement element, has been removed from it there. And force vibration, a constant force has been put up like this. You can say I'm forcing every time to make the structure to go into vibration. This will be called as force vibration. Now, this force vibration can be of periodic in nature or non-periodic in nature. Okay. Are now linear and non-linear vibration. If the basic component of a vibrating system, namely the spring, mass, and the damper, behave in linear manner, the resulting vibration caused are known as linear vibration. And non-linear vibration, if any of the basic component of the vibratory system behave in non-linear manner, the resulting vibration is called as non-linear vibration. Okay, now damped and undamped vibration. When a damping element is induced in a structure and the structure goes into vibration, that is called as damped vibration. And when that damping element is not present there and it is under free vibration or force vibration, that depends. That will be known as undamped vibration. Now the deterministic and random vibration. For deterministic, if the amount of excitation acting on a vibratory system is completely known precisely, the resulting vibration is known as deterministic vibration. And when this amount of excitation is not completely known, the resulting vibration will be known as non-deterministic vibration. Now next one is here longitudinal transfers and torsional vibration. See, uh, when the particle of the body or the shaft move perpendicular to the axis of the shaft, the vibration created are known as transverse vibration. If for the next, if the mass of the vibratory system moves up and down parallel to the axis of the shaft, the vibration are known as longitudinal vibration. If the shaft kept alternately twisted and untwisted on account of vibratory motion of the suspended disc, such vibration are called as torsional vibration. See, I'm making a figure here for more understanding. See, like this is with the figure, and now, if this is for transverse, we can say if this is a body over here and it is moving like from here to here, this will be a transverse vibration. And if the same body, if it is moving up and down, you can say up and down, this will be your longitudinal vibration. And if this disk, or you can say is this body is, let me clear it again. Now, for if this considered this a disk, if it is getting twisted, like rotating in first in clockwise, then again in anti-clockwise, then this type of vibration will be known as torsional vibration. Okay, now move on to our next slide. Consequences of vibration. Um, See the concept. First one is the overstressing and collapse of structure. Obvious, it is very obvious in nature. When the repetitive nature of the vibration acts on a structure, it will get, or large amount of energy will be stored and it will be damage or cracking and other damage requirement. Obvious, cracking may occur and other damage may also occur. Damage to safety related equipment. So yes, and impaired performance of equipment or delicate apparatus, adverse human response. We start getting panicked. Fatigue fracture, of course, fatigue fracture will also be there. Okay. Thank you for lecture one, and these are the references here. Uh, we will be meeting soon for lecture two.